In this video, I will work out all of the problems to practice worksheet number 1. Before we start, make sure you have written down the 3 key formulas. Theta equals inverse sine of opposite over hypotenuse. Theta equals inverse cosine of adjacent over hypotenuse. Theta equals inverse tangent of opposite over adjacent. Again, let's just recall how to label our angles. You're always going to think about standing in the angle theta, and you're going to label from there. So here's my adjacent side. I'm next to the angle theta. Here's my opposite side because I'm across from theta. And my hypotenuse is always across from the right angle. If theta is up here, right, it just changes how I label things. My hypotenuse is still across from the right angle, but now my opposite side is down here because this side is across from the angle, and my adjacent side is here, okay? So just be careful to label. Now, I want to show you actually the same problem that I can solve 3 different ways, and I'm going to use each formula once, okay? So this is kind of like a cool way to think about it, because in the event if you're given all 3 sides, it doesn't actually matter how you solve. Okay, so let's do this. Let's take angle T, and let's label 33 as my opposite side, which it is. And let's label 65 as my hypotenuse, which it is. It's across from the right angle. And let's ignore the 56 for 1 second. I want you to see that what I can do is use inverse sine because I have the opposite and I have the hypotenuse. I actually don't need this other side 56. So let's do this calculation. So theta equals inverse sine, right, of opposite 33 over hypotenuse of 65. And let's type this in the calculator, right? I love these problems because all I have to do is type them in. There's no algebra involved, okay? So inverse sine, so turn this on. And what did I say that was? 33 over 65. Okay, so that's gonna give me 30.5 degrees. So 30.5 degrees. Okay, now what's cool is I can solve problem number 2 using a different formula, and I should get the same angle measure. So let's try formula number 2. So 65 is my hypotenuse, but now let's use the 56. 56 is my adjacent side, and let's ignore the 33 this time, right? I only really need 2 sides to solve these. In this problem, I have the adjacent and hypotenuse, so I can use inverse cosine. So inverse cosine is adjacent 56 over hypotenuse of 65. Now, it's the same angle, right? I mean, angle T is the same in this problem and this problem. It should be the exact same answer. So let's type this in our calculator and see if it works. Inverse cosine of 56 divided by 65, and that gives me 30.5 degrees. So that's pretty cool. All right, so this just sort of goes to show you, in the rare event that you're actually given all 3 sides, it actually doesn't matter. As long as you use one of the formulas, you'll get the same thing. And now let's do our final formula. Let's use 56 as the adjacent, and 33 is the opposite, and this time let's ignore the hypotenuse. Well, here, if I have adjacent and opposite, I can use my inverse tangent formula. So I'm going to say that theta equals inverse tangent of opposite, right, that's 33, divided by adjacent, which is 56. And again, if I type this in my calculator, I should get the exact same answer. So just for some proof, so it's 33 over 56. So inverse tangent of 33 divided by 56, and I get 30.5 degrees. Okay, so that's just kind of a cool trick to understand. You only really need 2 sides to do these problems. So I hope that was helpful. If you have any questions at all, please send me an email and we can set up a time to chat.